Every time you use your phone for directions, satellites in space are quietly talking to it. But how does your device really know where you are? You are standing on Earth, yet your position is determined by signals coming from space. Here is how GPS actually finds you. Today we are breaking down how GPS knows exactly where you are. Despite satellites orbiting hundreds of kilometers above the planet, your device can pinpoint your location within just a few meters. And it all comes down to timing, geometry, and a bit of physics. What GPS actually is? GPS stands for Global Positioning System. At its core, GPS is not an app. It is not the internet. And it is not something stored inside your phone. GPS is a network of satellites orbiting Earth. The system is maintained by the United States Department of Defense. It was originally built for military navigation and targeting. Civilian access came later, once the system proved reliable. Today, GPS is used by everyone: drivers, pilots, ships, phones, fitness watches, even financial systems rely on it for timing. The full GPS system requires at least 24 operational satellites in orbit. They are spread across several orbital planes. This ensures that at any moment, multiple satellites are visible from almost anywhere on Earth. Your phone does not connect to all of them. It simply listens to the satellites that are currently overhead, usually 4 or more at a time. Your device never sends a signal back to the satellites. It only receives data. This is important for privacy and power efficiency, satellite signals and timing. Each GPS satellite continuously broadcasts a radio signal. That signal contains 2 critical pieces of information. First, the satellite's exact position in space. Second, an extremely precise timestamp. This timestamp is generated using atomic clocks on board the satellite. These clocks are accurate to within billionths of a second. Timing is everything in GPS. When your phone receives a signal, it compares the timestamp from the satellite with its own internal clock. The difference between those times tells the phone how long the signal took to arrive. Since radio waves travel at the speed of light, that time delay directly translates into distance. Even a tiny timing error matters. A mistake of just 1 microsecond can result in an error of hundreds of meters. That is why GPS relies on such precise clocks. Your phone's clock is not as accurate as an atomic clock. This is why GPS calculations require signals from multiple satellites to correct timing errors. Trilateration and how position is calculated. Once your device knows how far away each satellite is, it can start calculating position. This process is called trilateration. It is often confused with triangulation, but they are not the same. Triangulation uses angles. GPS uses distances. Imagine one satellite tells your phone it is 20,000 kilometers away. That places your phone somewhere on the surface of an invisible sphere. Add a second satellite. Now your position must be somewhere along the intersection of 2 spheres. Add a third satellite. Those intersections narrow down to a specific point on Earth's surface. With 3 satellites, your device can calculate latitude and longitude. That gives you a 2-dimensional position. A 4th satellite allows your device to calculate altitude. It also helps correct clock errors inside your phone. This is why GPS receivers usually wait for at least 4 satellite signals before locking your position. The more satellites your device can see, the better the result. Extra satellites improve accuracy and stability. They also help maintain location when signals are weak or partially blocked. Why you need multiple satellites. One satellite alone is not enough. With only one satellite, your location could be anywhere within a huge circular range. There is no way to narrow it down. 2 satellites reduce the uncertainty, but still leave a wide arc of possible positions. 3 satellites can narrow your location to a single point on a map. But that point assumes your device clock is perfectly accurate. In reality, phone clocks drift. They are not atomic clocks. The fourth satellite corrects this timing offset. It allows the system to solve for time error and altitude at the same time. Modern GPS receivers rarely stop at 4 satellites. They often use 8, 10, or even 12 signals simultaneously. More satellites means better geometry. Better geometry means smaller errors. This is why GPS works better outdoors than indoors. Buildings block signals. Trees absorb them. Urban environments reduce how many satellites your device can see. Sources of error and how GPS corrects them. GPS is extremely precise, but it is not perfect. One major source of error comes from Earth's atmosphere. As signals pass through the ionosphere and troposphere, they slow down slightly. This delay affects distance calculations. Satellite orbits are also not perfectly fixed. They shift slightly over time. These changes must be constantly tracked and corrected. Another issue is multipath error. This happens when signals bounce off buildings, walls, or terrain before reaching your phone. The signal arrives late, making the satellite seem farther away than it actually is. To reduce these errors, several correction techniques are used. Differential GPS uses ground stations at known locations. These stations compare GPS data with their true position and broadcast correction information. Assisted GPS, or AGPS, uses data from cellular networks. This helps phones find satellites faster and improve accuracy, especially in cities. With these corrections, civilian GPS accuracy is usually within 5 to 10 meters. With advanced systems, accuracy can reach sub-meter levels. GPS in everyday devices. Your phone does not rely on raw GPS alone. Most modern devices use hybrid positioning systems. This means GPS data is combined with other sources of information. Wi-Fi positioning helps identify nearby access points with known locations. Cell towers provide rough distance and direction estimates. Inertial sensors track motion using accelerometers and gyroscopes. Together, these systems fill in the gaps when GPS signals are weak or unavailable. This is why navigation still works inside tunnels for a short time. Your phone predicts movement based on speed and direction. GPS enables far more than just maps. It powers ride-sharing apps, fitness tracking, geotagged photos, emergency services, time synchronization for financial networks. Every time your location updates, your device is quietly listening to space. GPS does not see you. It does not track you visually. It measures time, and it measures distance. Satellites broadcast precise timestamps and positions. Your device listens, it calculates, and it pinpoints where you are. The next time your phone gives you directions, remember this. You are not just using an app. You are communicating with space.